Welcome back, Mustangs, to another edition of No Here, No Problem. Rosenwald here today with a new unit for us to be starting on. Today we're going to be talking about radians and degree measures. For my No Here, No Problem, today we've got a little Bartlett Fire Department hat that my kids loaned to me. I think I'm rocking this thing. I look stellar, man. I should have been a fireman. Woo! Put out the fire. Psst. I got this. Anyways, so today we're going to be working on radians and degrees, and this is going to be an introduction to a brand new concept to you guys. Remember, we're starting a new unit here where everything technically is brand new to you. We're going to tap into some prior information, but we're going to use that to kind of work through to get to the new information, okay? So without further ado, let's go ahead and get started here. I'm going to throw myself over here in the corner, make myself as small as possible because I don't look good on the camera. Let's roll. So today, radians and degree measures. First off, let's talk about angles and what we're going to actually be dealing with in this unit. We're going to be talking about trigonometry. Big unit trigonometry, very large unit, a lot of stuff that we're going to learn and go through. All the problems are fairly quick. They're fairly easy. It just takes a little bit of explaining to get you kind of to where we're at with things, okay? So where do we see these applications of the trigonometry and the waves that we're going to actually be dealing with, which are known as sine and cosine waves, and then you'll even see tangent ones as well. Well, we see them when we're talking about sound waves, light rays, planetary orbits that might be taking place, vibrating strings and like the resonance frequency of it, pendulums and the repetitious behavior of a pendulum, and then even the orbits of atomic particles, okay? So let's start off with, we have a bunch of new terms we're going to learn, so let's kind of get those going here. First one is an angle that's determined by rotating a ray about its endpoint. Okay, first of all, a ray. We have to remember the definition of a ray, which, remember, a ray is a point, an endpoint, and it's an arrow going in a direction. And what we're talking about doing is we're going to be taking this point right here, and we're going to be rotating it around. So we're going to be taking a ray and moving it around, okay? So what we're going to be doing is we're going to take a ray, we're going to go ahead and give it an endpoint, and we're going to move it. Now, where it begins at, the beginning point is called this side right here. It's called our initial side. It's where everything is going to start at. We're going to talk about something in this unit called a unit circle and the rotation of that circle, and everything's going to start from this point. We're going to talk about it in terms of polar coordinates. We're going to talk about it in terms of just the unit circle itself. We're going to talk about it in terms of how do we get to coterminal sides. There's a lot of stuff we're going to talk about, but we can't talk about it unless we understand the initial side is right here, that this is where everything starts, okay? What's going to happen is we go through the first quadrant, the second quadrant, third quadrant, and the fourth quadrant. So it's to be noted that we should remember each one of our quadrants, okay? Now, what I'm going to do is I'm going to take a line right here, and we're going to go ahead and call this our initial side of this, okay? And then what we're going to do is we're going to take that initial side, and we're going to go ahead and rotate it. So I'm going to duplicate this first so we can actually take it and rotate it. And what's going to happen is we're going to rotate it around until we get to this point over here. I could have easily just done this. I don't know why I didn't do that. Hang on one second. I'm going to delete that. And I'm going to go ahead and just take this point, and we're going to take that and drag it. And you see how it moves around, and it continues rotating around and around and around like this? Well, the side that's moving, generating an angle for us, is called the terminal side. That should make sense because it's moving, which is also what happens when you're going to go ahead and take a flight or a train. You go to the terminal. That's so you can move from one place to another place. It's to be noted a couple of things here. So what happens is when we have this line can technically go in this direction, right? It can go counterclockwise. This is called counterclockwise when it's going around and around and around that opposite direction. Well, we can also go the other direction, which is clockwise. The problem is, how do I distinguish I'm trying to communicate to somebody, how do I tell them, I don't know, turn to your left, turn to your right, right? Well, in the world of mathematics, we need two directions, and we call them the positive angles and the negative angles. So when we're looking at a positive angle, here's what's happening. We're going to look at the initial side right here, okay? We're going to just call that, I'll actually make that stable. We'll make that orange, okay? We'll just call that the initial side. Now, to make a positive angle, what happens is I'm going to go ahead and take this, and I'm going to move around, and by moving in this direction, in that counterclockwise direction, that's going to generate a positive angle for us. Versus if I started in this initial position right here and I start moving the opposite direction, which is clockwise, me moving in this direction is moving in what we call a negative angle. Okay? So to see that in action, I've got this right here. Pay attention to the left portion right here where it talks about the angle. Don't worry about the trigonometry terms that you're seeing here, cosine and all that stuff. Just watch the angle. That as I go ahead and move around to the left here, going counterclockwise, you can go ahead and see it's creating an angle, and what happens is it keeps going around all the way around until 360, and then I can keep going. Now, when we're doing this, I don't have to stop at 360 degrees. Just like figure skating, just like spinning around, I could keep spinning and keep spinning. And so you'll hear like, snowboarders, they do like a big wicked 1080. Well, how many revolutions did they do when they did a 1080, right? Versus if I went ahead and said, let's go ahead around to the right direction here. If I go to the right, you'll see my angle goes through a negative direction, okay? And I can keep going around and around and around and around. But what happens is I keep ending up in the same position. Those are called coterminal angles, which we'll get to that in 1 second when we get to those later in the sheet here, okay? So positive angles, counterclockwise, negative angles, clockwise, okay? So like linear functions, angle measures that continue forever in both directions, even though they're in the circular direction, those are called coterminal angles. Now, if I want to find a coterminal angle, let's break down what this actually says. Co, together, terminal, movement, or together in the same location. Here's what we're talking about here. We're talking about taking an angle, whatever the angle is, and we're adding or subtracting 360 degrees over and over and over and over. So for example, if I said, let's find a coterminal angle to 540 degrees, what angles would that get me to? Well, let's take the 540 and let's subtract 360 degrees from this, and let's add 360, and let's take away 360 from this. And if I do 540 minus 360, we get 180. It's late, so I'm going to check my math. I am tired. So 540 minus 360, we get 180 degrees, okay? And then when I do 540 plus 360, that's going to get me to 900 degrees. So 900 and then 180 and 540 should in theory be all in the exact same location. Now let's confirm that. Let's go ahead and look at first 540 degrees. So I'm going to go all the way around until we get to 540 degrees. I'm going to actually make the special angles here. So we get to 540 degrees. That's right there. Okay. Now, if I take away one full revolution, so I subtract 360, I go around to the back side here, and what's going to happen is I get back to 180 degrees. If I want to continue in the other direction and continue around, so I went 540, and then I go and I add another 360 degrees to this, that takes me around, all the way around back to this position of 900 degrees. So coterminal sides, there's an infinite number of solutions that are technically coterminal because I can keep going around and around and around. So that's what this n represents in our formula here. When we talk about how many times, that n is saying one more 360 degree rotation, or one less 360 degree rotation, or two more 360s, or two less. So the n just represents how many more times you want to go around adding or subtracting 360, okay? So now the nitty-gritty of this, let's get down to radian measures. What in the God's name is a radian measurement? Well, it's easy for us to talk about degrees when we're talking about a circle, right? When we talk about a circle, we're talking about this central angle, the angle that actually proves, right? The angle that I move, that actual movement that I'm walking through as I make this, as I go in this direction, this angle right here is all in degrees. But what about when I want to talk about this length right here? That length right there has a specific name. We call it a arc length. We also call it part of a circumference. But in the mathematical world, the connection between degrees and that length, we call a radian. Now, in order to do this translation, there's a whole video. I'm going to post this video not on here, but I'll go ahead and post it on our Schoology page. But it goes through it. I'm going to take you guys through it myself, okay? It says, remember that the circumference of a circle can be found by c is equal to 2 pi r, right? 2 pi. Let's talk about that number right there. 2 pi. you should recognize that 2 pi is really saying 2 times 3.14, right? We know that pi is equal to 3.14. At least I hope we all know that 3 pi is 1.4. And if I said that 2 pi, we get that that's equal to 6.28. Now we're going to get to this. I'm going to come back to these numbers in 1 second. But let's jump down here to the connection piece. In one circle, we know that we go through 360 degrees. And a half a revolution of a circle is 180 degrees. And so that means that if I was to navigate through this, if I go all the way around to here, I go 180 degrees. And if I go all the way around to here, I go 360 degrees. And I know that if I go just to this spot right here, I should be going 90 because 360 divided by 4 is equal to 90. So that means that this is a 90 and this is a 90 and 90 and 90, right? So each one of those is equal to 90 degrees. Well, what's the length in radians? What is a radian first off? Let's get to that. So a radian, this is the hard part, and you can actually see me, you can see me go through this in my unit circle video as well later on, okay? So if you don't get the first time, that's okay. But let's go ahead and look at this in terms of radians and why it's actually called a radian. So when we look at that segment right there, we know that a circle from the center to the outside, this length is called a radius. Now, if I was to take this radius, and I'm going to go ahead and duplicate this. So give me 1 sec. I'm going to try to do this live for you. And if I took this radius and I go ahead and I move it and I rotate it 90 degrees and put it right next to it right here, okay, you'll see it looks like a 90-degree angle, right? Now, we're talking about the curve of the shape. We're talking about this curve along my circle. So what happens if I take this line that's right here and I bend it so it actually fits on there? Well, if I bend it so it actually fits on here, here's what it's going to look like. It's going to actually fit right about, I'd say, maybe here. Would you agree? Okay. That looks about the same length, right? So this right here, when we look at this, this is an R, this is an R, this is an R. And if I go ahead and connect this up right here, we've got another R. All of these R's are a bunch of radius or radii. And this is why they call it a radian, because this angle that gets generated right here is considered 1 radian. My question for you is, if I was to take this and go ahead and move this all the way around my circle, how many of these sections right here do we think could actually fit in my entire circle? Well, let's see. So if I go ahead and I just go, let's say I'm going to take this portion right here, okay, and I'm going to go ahead and duplicate this, okay, and I'm going to rotate it so it fits on here nicely. Oops, we're going to rotate that. I'm going to try to get this to move over here. I'm having a little trouble. Sorry, dang technology. Okay, and I'm going to curve it so it actually fits up with this nicely here. Okay, and I'm going to go ahead and change the style, and we're going to make it green. So we can see that there's 2 of these right here. Okay, let's go ahead and take this and let's duplicate it, and we're going to move it now this way and move it over to here. And I'm going to move it down here, and I'm going to curve this a little bit so it fits up a little bit better. And let's go ahead and change the style so it's red, and there you go. So from what we can see at this moment, there are 1, 2, 3 of these in, when we look at this, 180 degrees. So my question for you is, how many of these could have fit in 180 degrees? How much do we think is left right here? Well, we know there's 3. I'll let you think about it for a second. Believe it or not, there are 0.14 that go right there. That means that when we look at a circle in 180 degrees, there are pi radians. 180 degrees is the same as saying 3.14 radians. Okay, but we just use pi to represent that number, right? Now, with that said, I should then be able to go ahead and say, well, let's go ahead and clean this up here. Oops, I didn't want to delete that. And let's go ahead and get rid of all this. And I'm wondering if I was to go ahead and take that whole thing that we see right there and duplicate it, what would that give us? Well, if I took this portion, how can I do this here? let's go ahead and just take my circle and move it for 1 second. So I'm going to take my circle, I'm going to go ahead and move it for 1 second. I'm going to go ahead and get rid of this because we really truly don't need that. And I'm going to go ahead and take this all, and I'm going to go ahead and duplicate this, and I'm going to take this and go ahead and rotate this. Okay, and holy smokes. Okay, and I do the same thing over on this side. Technology as best, you guys, right here. There we go. All right, you'll see that what ends up happening is we have the exact same thing happen right here as we do over here. That we end up with an extra 0.14. So in order for us to get all the way around 360 degrees here, to go all the way around 360 degrees is the same then as saying 2 pi radians. So what if I wanted to do a conversion between degrees and radians? What is that going to look like for us? Well, there's a conversion that we use that to get from a degree to a radian, you take whatever the degree is and you just multiply it by pi over 180. Okay? And then in order for us to do a conversion to get from from radians to degrees, basically what you do is you take whatever the radian is, you multiply it by 180 over pi, or it's the same thing as taking your pi and just replacing it with a 180. What are we talking about here? Well, let's see these in action so we can kind of wrap our minds around this, okay? When we look at, and I'm going to keep referencing back to I'm going to make a little circle for us so we can kind of reference where these are at here. Okay, I want to do that a little bit better. Okay, and then I'm going to make a little circle so we can actually reference it. All right, and then I'm going to go ahead and duplicate this, and we're going to do this repeatedly. Okay. I'll make more later in a second here. So when we say 0 degrees, what we're saying is right here, 0 degrees. We're talking about at that starting point, that's at 0 degrees right there, okay? Well, at 0 degrees, I have not moved at all in this direction, have I? And so because of that, I have also gone 0 radians. So we have 0 radians, okay? We don't even have to write pi, we just write 0, and we don't use a degree symbol because we're not talking about degrees, we're talking about radians. Okay, let's look at the next one. So for me to go 30 degrees here, when we say 30 degrees, what does that look like? Well, here's the terminal side. 30 degrees is going to take us to about, here, I'll do this in blue. It's going to take me to about here. Okay, well, how many radians have I gone through? Should be right around 1, maybe a little less than 1. But the conversion when we do this is to say 30 times pi over 180. Now, I want you guys to get used to doing this. Take this 180 that's right here, and really, let's throw it over on this portion, so it's underneath the 30. So we have 30 over 180, and then we have a pi. Okay? Well, 30 over 180 reduces to just 1/6, and then you have pi. Now, we don't normally write it as 1/6 pi. What's actually happening is we write it then as just pi over 6. There you go. Now, let's check this, okay? We said that this should equal approximately 1 radian. And if we go ahead and do this, let's go and take pi and divide it by 6. Pi divided by 6 is equal to 0.5235. So that's a little actually less than half of 1 radian. So I'm a little off as far as like how this is getting measured on here because it's so small. But the actual measurement of 1 radian is if I was to take 180 and divide it by pi, we actually get that 1 radian is equal to 57.3 degrees. Okay? And so because we're looking at 30 degrees, it's a little less. I said it should be about 1. It's about half of 1, and that's why it's 0.5235 radians. So 30 degrees is the same as pi over 6 radians. Okay, and again, real easy way to look at this is to say right here, treat that like it's a 180. 180 divided by 6 equals 30. Okay, this is one of our common special ones. All right, let's go to our 45 here. Let's do the conversion. Okay, let's go ahead and duplicate first before I lose that. Let's duplicate again before we lose that. Okay, so knowing that we just said that 1 radian is equal to 57.3 degrees, And again, we get that because we did 180 divided by pi, which is 180 divided by 3.14. That's where we get that 57.3. We know that this should be a little bit less than 1. Let's do the conversion. Ready? 45 times pi over 180 means that this will reduce to just pi over 4 because 45 over 180 is 1/4. And again, if I go ahead and do pi divided by 4, we get that that's equal to 0.7853 radians, 54 radians, okay? So it's less than 1 full radian, okay? Now 60 degrees is bigger than 57.3. So that means that we should end up with something that's a little bit larger than 1 radian, okay? So if I go 60 times pi divided by 180, what we end up with is pi over 3, because 60 over 180 is just 1/3. And if we looked at this as 3.14 divided by 3, we end up with, like we just said, a little more than 1. We get 1.05 radians, okay? Now, I'm not too worried about the radians right now. We're just working on doing conversions. So let's just keep doing these conversions so you guys can get used to seeing these are the most common ones. And we'll talk about why a little bit later here, okay? But let's go ahead and duplicate that. Let's duplicate that. Let's duplicate this. And then I think that should be it. All right, so 90 degrees. Let's keep going. Let's start ramming through these here. So 90 pi over 180. That's going to reduce 90 over 180. It's just going to be pi over 2. Okay, 180 degrees, we're going to go 180 times pi over 180, which means we're going to have the 180's cancel, so we're just left with pi, and we already know that from above that 1 pi is equal to 180, 180 degrees. All right, 270 degrees, multiply that by pi over 180, and we're going to end up with 3 pi over 2. And then 360 degrees is going to end up being pi over 180, which just equals 2 pi, okay? And again, to let our minds wrap around these, all right, 45 degrees is going to be right here, okay? You know, I got to use something not so chunky there. 45 degrees is going to be right here. 60 degrees is going to be a little bit more than that. 90 degrees is going to be right up above here. And again, these are all based off of moving from the terminal side. 180 degrees will be right here because I went all the way around to 180. I said terminal side from the initial side. 270 degrees will take me all the way around to here, so I'm going to be at this position. 360 degrees will take me all the way around back to the beginning, and we're right there at 360 degrees, which we said is 2 pi. Okay? All right, so practicing doing more conversions for degrees to radians when it's not such a clean, pretty number. This is just practice. Feel free to go ahead and pause it, try it, check your answers. But we're just going 50 times pi over 180, which will then just reduce to 5 pi over 18. We're going to go 80 times pi over 180, which this will reduce to, I can't do mental math right now, I'm too tired, 4 pi over 9. Okay, 150 times pi over 180. We're going to go ahead and get 150 over 180. I should know this one offhand. It's 5 pi over 6. Okay, and then 240 times pi over 180. We're going to get, that should be reduced to, again, I should know this, and it's going to be 4 pi over 3. Okay, and that's it. Oh, 300, sorry. 300, we're going to multiply that by pi over 180. Okay, and again, 300 over 180, we're going to get, that should be, 5 pi over 3. Okay. All right, so that completes the degrees to radians. Now let's do radians to degrees and do this quick conversion, okay? When we're doing radians into degrees, remember what we're doing is we're taking and we're multiplying 180 by 180 over pi. So realistically, as I said, the pi's cancel. We could really just say then it becomes 180 over 8, which is just, when we divide that out, it's just going to equal 22.5 degrees. So if you remember my shortcut up above, I said basically just anytime you see a pi and we're converting it over 2 degrees, just treat pi like it's a 180. So this becomes like a 180 over 12. It's like a little shortcut there. We get 15 degrees, okay? Then we do 180 divided by 4 times 7. Again, this is going to be 180 right here, and that's going to be 315 degrees. Okay. Shortcut here, to show you guys how to do this really quickly mentally. The 180 over 3 we know is equal to 60, and 60 times 2 is just 120 degrees. Okay, we're just doing quick conversions here. So again, right here we go 11 times 180 over 6. This 180 over 6 is just 30. And so 30 times 10 is 300. 30 times 11 is 330. That's a wonky 3. So 330 degrees. Okay. All right, so talking about supplementary and complementary, remember that supplementary, by definition, these are two angles that add up to 90, and supplementary are two angles that add up to 180 degrees. So if it's possible, we're going to find the complement and the supplement for each one of these, okay? Complement for this is that we have 90 minus 72, which means we have 18 degrees. The supplement is going to be 180 minus 72, which means we're going to have to 108 degrees. Okay. For letter B, the complement is going to be 90 minus 148, which does not exist, not possible, whatever you want to call it. And supplementary is going to be 180 minus 148, which leaves us with 32 degrees. Okay. Believe it or not, we're going to be using this a lot when we actually start deriving the unit circle and we start talking about what's called reference angles, but we'll get to that in next sections here, okay? For right now, let's keep focusing on this, okay? So when we talk about complementary, remember, if we say that they're going to add up to 90 degrees, if you recall from up above, is the same as saying pi over 4, okay? That's the same as doing just, pi over 2. Okay, 90 degrees is the same as saying pi over 2. So for it to be a complementary angle, I would have to take 90 minus 4 pi over 5, if that's even possible. Okay, so this is where you start to get good at doing fractions, you know, crisscross applesauce or whatever it is, try to do the subtraction. If I do the subtraction here, this will be 5 minus 8 over 10 pi, which is going to equal negative 3 over 10 pi, which does not exist. There's no complement to this. Now, because some of you are not comfortable with this yet, this is going to be technically new for everybody, right? We can look at this and see if there's actually a complement if we were talking about this in terms of degrees. 4 times 180 divided by 5 is the same as saying 720 divided by 5, which is equal to 720 divided by 5, which is 144 degrees. There's no complement for 144 degrees. So that's why we have a does not exist for the complement. When we say supplementary, remember that adds up to 180 degrees. And so that's the same as saying pi, right? So if I do pi and I take away 4 over 5 pi, that means we're going to have, you can look at this as 5 over 5 because 1 is the same as 5 over 5. 5 over 5 minus 4 over 5 leaves us with just 1 over 5 pi. Okay? And so that is the supplement to this. Now again, let's just confirm this, right? 4 pi over 5 is the same as 144 degrees. Okay? So if I looked at this one in terms of degrees, that's 180 over 5, which is the same as 36 degrees. And if we look at these two, those add up to 180 degrees. So we're working in degrees or radians, whichever you're comfortable with. But if I start with the problem in radians, the answer has to be also in radians. Okay? All right, last one here, 2 pi over 5. So I'm going to do this in radians. Got to get comfortable with it. This, we're talking about radians. 90 degrees is the same as pi over 2. And we're going to take away 2 pi over 5. Okay? So that means that when I look at this, if I want to get the denominators to be the same, I multiply this by 5, multiply this by 5, multiply this by 2, multiply this by 2. And we have 5 pi over 10 minus 4 pi over 10, which just equals pi over 10. That is the complement. The supplement for this, we know that 180 degrees is the same as pi. So I do pi minus that 2 pi over 5. And again, to get the denominators to be the same, I say 5 over 5. Same exact denominators, right? And that's equal to just 1 pi. That means that this is going to equal 3 pi over 5. That's it. All right, so that's the majority of this first section. The last thing to talk about, which is going to segue into the next sections here, and this is like literally, like this is the main portion of this entire unit. It stems around everything that you should know from previous stuff with geometry. Now we're just going to use it in higher level stuff. First thing we have to know is a 30, 60, 90 triangle. Now we have the saying that 30, 60, 90 triangles are as easy as 1, 2, 3. Right? That's what we say. Easy as 1, 2, 3. Now we mess around with it a little bit. Believe it or not, there's actually a root 3 in here. But it's as easy as 1, 2, 3. So when we look at root 3, that is the same as 1.73. And we should remember that there's a property that says that smaller angles produce smaller sides, bigger angles produce bigger sides. So if these two right here are generating a side from this angle, if this angle is 30 degrees, then this side right here is the side opposite that gets generated from these angles, right? So that's the smallest one, which means that this one is just equal to a 1. If I go ahead and I look at this angle right here, which we got, these two are projecting out right here, coming from this 60-degree angle right here, well, they make this side that's over here, right? And so since they make that side that's over there, that side over there is the next size, which is going to be root 3. And then our hypotenuse is always the biggest side, which is 2. Okay. With 45, 45, 90 triangles, we have a rule that says 1 and 1 is 2, baby. 1 and 1 is 2, right? But again, just like in the previous one, there's a root in this. And so the root is right there on the 2. Well, we have two sides in this picture that should be exactly the same, right? This side generates is opposite my 45, and this side is opposite my 45. That means that this is 1 and this is 1. Got that 45 twice, so the side's twice, 1 and 1. And then my hypotenuse is a root 2. So that's it. You need to have those memorized to be successful in this unit. That's it in a nutshell, you guys. Make sure you understand this. If you have any questions, please ask. But this is like so important that you understand the front end of this unit, okay? Until next time, you guys be safe, be responsible, be respectful. Don't forget to like and subscribe to my channel. Take care and have a great day. We'll see you.